Yo, what is up, Precalc students? I heard that this homework is short. I got a little bit of time here to do it before we have class on a Friday. We are talking about residuals, error, over under approximations based on models. The only thing I remember, I don't memorize anything else, is that a residual, if I could spell, is an actual value from your data. Actual comes from data. Actual comes from like what's given to you minus your predicted. Predicted comes from your model. Cool? Now it should make sense. If your actual is bigger than your predicted, your residual is going to be positive. But then think about it the other way. Your prediction is going to be an underestimate. So when your residual is positive, it means your predicted is less than the actual. Okay, so it's a little bit opposite of what you kind of expect, but it's good to understand. If the residual is greater than zero, we're talking about predicted being predicted being less than actual. If your predicted is less than actual, you're talking about your prediction is under what the actual is. If your residual is negative, you're talking about your predicted value from your model being greater than your actual. If your predicted value from your model is greater than your actual, you talk about over approximation. It's the first thing we talked about. Second thing we talked about is like how residuals help you pick the right model. Okay. Now I made this homework and I had this data. And if you want to go ahead and do this yourself, you can. Plugged in this data. I purposely made this data be practically linear. Okay. The average rate of change is almost consistently 3, but not exactly 3. Okay. I ran 2 regressions, an exponential regression, a linear regression, and then I produced the residuals, the actual minus predicted, which is what we did. The other part to this lesson, besides like over and under approximations and residuals, is how residual plots help you understand which model looks good. And it's almost like a little bit weird because this is the residual plot for our linear approximation, our linear regression. Here are the residuals. Now, these should all be 0.1s. This should 0.2, 0.3, 0.4. I don't know why they don't show up, but whatever. What you will find, again, this is going to be the winner because we know this is practically linear. Okay, so this is going to be the winner. But when we plot our residuals, is that it's a little bit all over the place. We got some things that are below. We got some things that are above. We got hopefully residuals that are going to be close to zero. That's kind of a big thing that I think of when I'm talking about what's your best model. Well, it's going to produce the smallest residuals, which means you're going to be the most accurate. AP Precalculus doesn't really care about that. AP Precalculus more likes to see, if there is randomness in your residual plot, that's good. If there is a clear pattern in your residual plot, that's bad. Here's the last 2 right there. So you can see the points are kind of all over the place, and we do have a lot of residuals that are close to 0. Now, again, actually, these residuals are close to 0. These are all 0.5, 0.4, 0.3, 0.2, 0.1. Versus now we're talking about positive 5, 4, 3, 2, 1, negative 1. We're not talking about points. So think about this graph almost being, heck, no, I'm not going to do it. I'm going to be like, I'm doing it actually this way. I have barely any error. This is actually what I want. I want to do this. Just to show, man, you're close. We're really close. We're really accurate. We have very small residuals, and it's kind of scattered. Versus, man, residuals of 4.4 is down here. Negative 2.4 down here. Negative 1.1 here. 0.7 here. 1.9 there. 2.2 here. 2 here. 0.9, which is going to be here. 0.1, which is there. And negative 2.1, which is there. You can see your residuals, first of all, not close to zero. And they make this pattern, which just shows like this is not good. This is a bad model. Pattern means bad model. No pattern, small residuals, good model. Cool? Cool. Let's go, actually, I'm sorry to do this, to the multiple choice questions. I'm going to skip these questions, go straight to the multiple choice questions, which kind of talk about that second part. Pattern means pattern and big residuals, bad model. No pattern, small residuals, good model. A quadratic regression was used to model a data set. This is the residual plot. Which of the following statements about the appropriateness of... So again, this is not the plot of the data. This is a plot of the residuals. You can see the residuals are like negative 2.5, negative 1.1, 0.1, get all the way to like 2.5. The residuals are large and they're showing a pattern. You might think that this data is quadratic and quadratic is good, but this is not a graph of the data set. This is the graph of the residuals. Since this is a graph of the residuals, the quadratic model is bad. Whatever the data looks like, it doesn't look like a quadratic. Probably the original data may be something like exponential or linear. So here's your data. Here are your residuals. This is a bad model to choose. It's not appropriate because it shows a pattern and we got big residuals. Okay, I like this question better because this is the data. This is the residuals. Okay, the data is exponential for sure. We can see that the data is exponential. If we ran a regression, that was an exponential regression. An exponential regression, the residuals would be the following. The residuals would be close to zero, and they would be kind of randomized, positives and negatives. See that? Kind of just what we did on the first page. We ran the linear regression. We saw them close to zero. We had some positives and negatives versus our exponential regression made this quadratic. An exponential regression would look like this. A bad regression would look like that. We have big residuals and they make a pattern. So the data is exponential, but the regression rerun, which is bad, creates this residual plot. So that means I must have run something that's not an exponential. I must have run a quadratic regression. If I ran an exponential regression, I would have looked at that. And I would have been like, exponential regression, perfect. We're talking about probably residuals that are close to or at zero. Here, the quadratic regression must have been run. The quadratic regression doesn't fit. It creates this residual plot. The model is not appropriate. We don't want to see this kind of pattern. It is an indication that we picked the wrong model. A set of data was used to create a linear, a quadratic, and an exponential regression. Which model would be the most appropriate? Well, like you can see, big residuals, very tiny residuals. A pattern that's established, no pattern that's established. The exponential regression is the winner. Small residuals, no pattern, bam. Boom. We're using a quadratic regression. We do the residuals. They're close to zero. They're no pattern. Good choice. Quadratic regression wins. The quadratic regression produces a residual plot that displays no apparent pattern. the quadratic model is a good choice. Okay, that was like the second half of class. Get those over with. Now let's get to the first half of class, which is run models, talk about residuals, talk about over and under estimates, which is just this page, and it's going to be a piece of cake. So let's go. Stat, edit, data. Bam, 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 boom. So when I worked in finance, I entered in a lot of data. So like I got really good at using the keypad. I had to put together models for companies, like their profit and loss statements, their balance sheets. I had to get their data off of like websites, type it into my own model, and then make predictions. Like I modeled a lot when I worked in finance, and you get good at typing in data. All right, we're talking about number of cars in the U.S. per 1,000 people, how they grow exponentially. Let's use an exponential model, stat calc exponential regression. We will store it in Y1. And there it is. What is the equation? Y equals, we'll see, like we sometimes use Y hat for our model as like, this is my approximate model. This is the actual data. You don't have to. It says Y equals. I'm just going to stick with Y equals. Remember, we want to keep all of our decimals when we're making predictions, but for just writing down answers on the AP pre-calculus test, 3 decimals are appropriate. According to the model, how many cars were found in the year 1935? I gotta think about this. This is several years from 1920. So this is 1920. This is 1930. 1935 would be at 15. Okay. So don't go to 35. I'm assuming that X years since 1920 means this is 1920. So we go. Okay, now again, we can graph our data. We could have seen that it's exponential. Remember how to graph your data, turn on your stat plots, go ahead and zoom stat. It fits all of your data points. You can see your exponential model. This is a good place to see predicted minus actuals. You can see your predicted is over the actual, which means we're going to have a negative residual. Here's my predicted under my actual. We'll have a positive residual. But we want to figure out what my model says at 15. I'm just going to go ahead and go into the home screen and do Y1 at 15. This will be just a little bit quicker to calculate all the stuff. So Y1 at 15 is 190.979. Okay, cool. Not people, cars per 1,000 people. Find the residual for the year 1980. So 30, 40, 50, 60, 70, 80. This is 1980 over here. Bam. All right, so that's year 60. Let's find the data at year 60. The actual was 710. Let's find the predicted. Actual comes from the data. Predicted comes from your model. Let's go Y1 at 60. We could have also looked at this. Let's just make sure we see it. The predicted is bigger than the actual. The predicted is 768.089. The actual minus the predicted will produce a negative residual. The residual is 710.21 minus That number, that's a negative 57.87. That's a big residual. Maybe this is not a good model. Maybe we should have picked a linear model. I don't know. Anyways, what is that telling me? Predicted bigger than actual, negative residual. Negative residual means we have an overestimate for this location. My model overestimates my actual. Negative residual, predicted is bigger than actual. All right, last one. Stat, edit. Don't delete. Clear. Clear. Press enter after you press clear. Don't delete. Clear. Enter. I didn't get much sleep last night. I'm being a little bit goofy. I woke up in the middle of the night with a sore throat. That's always fun, right? Waking up in the middle of the night with a sore throat. Always fun. I'm highly caffeinated as well. Linear. Stack. Calc. Linreg. This one. Okay, fine. That one. Sure. You'll get the same thing, just in different forms. Who cares? Just make sure you write down the equation after it's produced. There's a and b in y equals a plus bx. So here's my regression. Y equals a. I should just put 3 decimal places. Plus b. You can round this up if you want to. X. This is years since 1950. Like, I don't know why we're doing this. You could also just have 1950, and then that makes it easy, but whatever. Population of 1979. This dude, Mr. Passwater, is like a pre-calculus materials making machine. So he stole a lot of this stuff. Because I'm tired of making stuff. All right, so this is 1960. This is 1970. 1980 would be here. 1979 would be 29. Right. So y of 29 equals, I'm not even going to see my data. I don't need to. Alpha y1 of 29. As long as I stored my equation in y1, which I did. Zoom stat, if you want to see it. It's good to see. Okay. Under approximation, over approximation, over approximation, over approximation. Yo, they're going to be very small residuals. They're going to be over and under, which means positive and negative, negative and positive residuals. If you want to go into trace, boom, 29. 4.527, 4.527, bam. This is the world population in billions. Residual for 1990. 1980, 1990. 1990 is 40. Okay. So, actual. 5.32. Predicted. $40. 5.384. Predicted. Close to the actual. Nice job, regression. You are accurate. You have a small residual versus the last one. The residual is big. Predicted. Bigger than actual. Residual will be negative. Negative residual overestimate. Gosh, can't we just get two different things where we have an underestimate, which is a positive residual? Whatever. If you do it a couple times, you're fine. 5.32. Let me just make sure that's right. 5.32 minus that number. There's my residual. There's like my error, how far off I am. And you can just see. Now, what's important is that sometimes, like on your quizzes and stuff, we're going to tell you, hey, you have a positive residual. What does that mean? you won't be able to look at your predicted versus your actual and say your prediction was an overestimate of the actual. You'll have to just kind of do the thought process. Don't memorize things, rather just keep in mind actual minus predicted. If you're going to have to memorize anything, you memorize that. It's actual minus predicted. How far off your predicted is from your actual, not the other way around. Keep that in your brain and you're good. All right, I'm out. That was fun.